Okay, I wanted to start with a bearing problem today, and so the kids are working on it right now, and I'll summarize it for the video. You start here where it says start, right here, and you head 1 mile in a northeasterly direction, 1 mile northeast. I could have said that in true bearings. If you want it in true bearings, true bearing, it would have been 45 degrees true. That's how you'd say that in true bearings. Okay, and they head that way for 1 mile, and then they stop right there, and you always put down another compass rose where you stop. And then we're going to take a 290 degree bearing to the next spot. That's going to be like this. That'd be 270, so that's 290. All right. And then we go for 3 miles in that direction. We stop right here. And realize that the story behind it was you were walking from your car. First you went up to the top of a mountain here, and then you realized that you thought there was a cabin over here, and so you walked over there, but there wasn't a cabin, so no help there. Got to walk back to your car because you're more likely to be rescued if you stay by your car. So this last dotted pink line, the question is how far is it going to be to get back to your car, and what's the bearing you would need to go at? So I reminded the kids that you do have right triangles. You have one here, and you have one here, and you have another right triangle right, oh, try that again, right there. So you can get 3 right triangles. All right, I'm going to let the kids have some time to try to figure this out themselves. Pause for a second. By the way, you'd totally be able to use a calculator on this, so you definitely can use a calculator, find your answers for decimal angles, and how far is this as a decimal. I am not going to delude myself into thinking, just because I know how to do this, that automatically means you would know how to do it. But there's some things I'm hoping you could figure out. Would you agree that this has to be 45 and then therefore this has to be 45 degrees because of how northeast works? Okay, that's something you should know. All right, next. If that's 45, then do you get these can transfer over here, and these must also be 45 degree angles. Okay, and then last but not least, do you get that this right triangle is a 45, 45, 90, and therefore you can know all of its sides. You can figure that out. Okay. Now, I would do it by hand by making the helper triangle like this, 1, 1, square root of 2, and that's how I would do it. And I would say, what do I have to do to get this to be a 1? I'd divide everything by square root of 2. Now, you don't have to do it this way, but the sides do turn out to be 1 over the square root of 2. All right, I'm going to put in these 2 triangles. And next, I got to figure out, don't I have some angles in this one? The blue one? Oh, yes, I do. Because of how we're using north, south, east, and west, I can guarantee you that is a right angle up there. And next, since the total was 290 degrees back here, since that was 290, to here would have been 270, it went 20 more than that. This was a 20 degree angle right there. And if that's a 20, that's a 20. Do you remember the deal where when you have a transversal and something cuts through, that this and this are going to be what are called alternate interiors? They're going to be the same. All right, so you got to be able to transfer this 20 down here to this 20 up here. And I know I didn't draw it perfectly. It's probably a little too big for a 20 degree angle, but okay. Now I know this one's 90. So together that would be 110 to there. That doesn't really help, though. Okay, but would you agree that I've got a right triangle where I have an angle and I have a side? So once again, I can know all of these sides in the bright blue triangle. And last, of course, there's this triangle. This is the most problematic triangle. Do you know why? Because I don't know any of its sides, and I don't know any of its angles. I can figure them out, but I don't start knowing any of the sides, and I don't start knowing any of the angles. You might assume that one of those angles is 45. It is not. So that's the hardest triangle. So here's what you do. You give these names. To get used to this now, I'm going to always call the ones that are in the horizontal direction like this, I'm going to call that H. And since it's the widest one, I'm going to call it H tot for total horizontal distance. Would you agree that this side here is also a horizontal distance, but it's not the total? I'm going to call it H1. And last but not least, I'm going to call this distance from here to here H2. Would you agree that H1 plus H2 would have to equal H total? Do you get how that works? That's the key right there. And then this I'm going to call V total, vertical total, and I'm going to call this V1, and I'm going to call this distance, which I've already figured out, V2. But I said, I don't know this, but I do know this because it's on a triangle where I have a side and an angle, and I do know this because it's on a triangle where I have a side and an angle. And so then I can take V1 plus V2, and I'll know my total here. All right. I'd like you to give this a try. Finish it off. What we're really trying to find here, I'll make it this squiggly black side right there. That's the side we are trying to find. All right. So I already know this one is 1 over the square root of 2. Now you could have used sine, cosine, and tangent to do that too. But I'm going to figure out that decimal. And that one's 0.707 or 0.71. How many of you had 0.71 for that one? Okay, that's a good start. How about this one? Well, that's the same because this is a 45, 45, 90. So that's also 0.71. I'd be thinking, why do you care? You need this one. To get this one, I have to get it by finding this one and this one and subtracting them. All right, so next I'm going to use, I got my one angle and my one side in my right triangle. All I need, I'll go sine of 20. Oh, that's opposite of hypotenuse. That's not going to work. I want to use cosine of 20. Adjacent, which is the H tot, over hypotenuse of 3. And so 3 times cosine of 20. 3 times cosine 20. Did you get 2.81 for this distance here? Raise your hand if you had 2.81. Okay, that's a good sign. Most people are getting that. And if this one's 0.71 and this one's 2.81, I can subtract those two. So I take my 2.81, technically it's 2.812, minus 0.71. Now, do you get I rounded? And so my answer of 2.11 for this could be off a slight bit compared to yours. So if you got like, but Mr. Server, I got 2.099, that's really close. Okay. So, I'm going to just leave it at, let's get the final answer here. V tot comes from V1, which we can find, and V2, which we already know. And would somebody tell me, what did you get for the vertical total? AW in the back, what'd you get? 1.7 what? Can anybody verify 1.73? A lot of nodding heads, awesome. Then, what's the final answer? Well, I'd use a squared plus b squared equals c squared. Because this is a right triangle, And I can take that squared, and then take the square root of those two things added together. And what'd you get, Mr. H? 7 what? 2.73. Anybody else get 2.73? Awesome. Now the harder question. How far, in what direction? All right. Well, you need to be able to find this theta angle by using these two nice numbers, 1.73 and 2.11. So I'm going to give you a side little problem. Everybody, if your partner or you don't know how to find theta in this example, you're going to be toast on the test. So everybody right now, make sure your partner knows how to use inverse functions. Both of you use your calculator, and if you both can't get it, show them how you got it. You do not need to find the hypotenuse to do this. If I were you, I'd just use tangent. Pausing for a second. Okay, what'd you guys get? I couldn't hear any of those. 53.9, close enough? All right. And you do inverse tangent on both sides. And theta is inverse tangent of 11/8. All right, so that's the exact answer, by the way. If the test asks for the exact answer, that's the exact answer. Do you get the decimal answer? Seems maybe more exact, but it's not because you have to round it. Okay. All right, so back to this problem that we were on. I had this side and this side, and now that's enough to tell me this side, and also it's enough to tell me this angle. Is that the bearing? No. That angle right here, this theta, it's a good angle to know, but it's not the bearing. You should have done tangent of theta would be the 2.11 over 1.73. So you do inverse tan of 2.11 over 1.73, and you get some angle, and it's like 30 degrees or something like that. What was it? Did you get it, Mr. H? 51? Anybody verify 51? Okay. Then, if this angle right here is 51, if that's 51, what's the rest of it? Because that is the bearing. It's not the 51, it's the rest of it here. So it's 180 minus the 51 would be your final answer. And I got 129. Raise your hand if you had 129. All right. Okay. Now, I may have drawn my triangle slightly different than it was supposed to be. Do you get that I might not have had a perfect angle right there? Would that throw it off a little bit? Yep. Do you get that I might not have made this exactly 3 times as big as the original distance here? That might not be exactly 3 times as big. So, like, if I just redo this problem quick and I say if this was 1 and it was actually 3 was actually this long instead of like how long I had it, do you get how it slightly changes the angle? You can't trust the angles you've drawn unless you've drawn it perfectly. Anybody want to sign up for drawing it absolutely perfectly? That's going to be really hard. But do you get if the ratio is 3 to 1, and I say this is 1, and then I draw this 2 and say it's 3, do you get how my triangle's really going to be messed up? If it's supposed to be 3 times as big and I draw it like that, it's going to look like I'm supposed to head straight south. Am I really? No. Because if I really make it 3, it should be 3 times as big as this first side. So if I make it 3, it should be at least that long. You get what I'm saying? And now all of a sudden, you can tell you're not going to head straight south to get back to here. You're going to definitely head at more of a this angle. Okay, yes?
For the bearing, I wrote like south with like eastern south like a different.
Good question. I would have accepted an answer. I'll give you an example. In this case, that angle right here was 50. What was it again? 51. What was it again? 50.6, thank you. Then you could have said that this was south 50.6 east. That would have been an accepted answer. But you need to know the difference because you're going to see true bearings on your test. That is the true bearings. All right? Just to make sure you're good at that, I'm going to give you one more of those. Everybody make a compass rose and just see if you and your partner both know where this is. Draw 260 true bearing. Head in the direction from the middle of that little compass rose. 260 true bearing. Compare with what they have. You should have said something like that. Raise your hand if you had that right. Okay, good. Now, tell me what that is in not true bearing. If it's 260 in true, give me a way to say it with easts and wests and norths and souths. So coming from here, you'd head south, but then you'd course correct how much? So you could say south, but 80 degrees in which direction did you course correct? West. That would work. Or you could say west, then course correct how far south of that? 10 degrees south. I would have accepted any of those answers. But I'm not going to interpret it for you. If the test says 210 true bearing, you have to know where that is. I'm not going to change it to, can you make that into like south 20 west or whatever? No, I won't do that. You have to know how to do your bearings. All right, so I want to give you one now that starts from scratch, and the other one I had already like made the picture for. So here's one. There's no picture. And I'd like you to start with, this is a scenario where you're on the ocean, you're sailing around the Caribbean, and your boat just sank. Maybe you hit a rock. Maybe you don't even know what happened, but all of a sudden your boat's filling up with water, and you jump out in your life raft. Thankfully you got the life raft going. And you got a little GPS, and you can tell that from wherever you boat just sank, at first you go north 10 degrees west for 2 miles. Maybe that's the current is like washing you in that direction. There's a lot of currents out in the ocean. And then all of a sudden maybe a big wind kicks up. It starts blowing you and you head 160 true for 5 miles. The question is, from where your boat sank, how far would it be to get back to where your boat sank? Now in this case, it's not nearly so important to stay with your car because your boat sank. People can't see where your boat is. It's under the water. So in this scenario, there's no reason to try to stay by the car. But we want to know how far you are from the car. So to start with, I just pick a place like right in the middle of my iPad, and I would make a compass rose, and I try to figure out which way that is. I'm heading 10 north, but 10 degrees west of that. Did you guys realize you were kind of headed that way? And then you go that for like 2 miles. Okay, well, maybe I'm okay. If you have to, you can always grab this stuff and like move it to make more room. Now I got to figure out which way 200 or 160 true is. So I'm going to move this over a little bit. Wherever you stop, you put another compass rose. How many of you had already put in a second compass rose? Okay, good. Then you've got the hang of it. Now try to go 160 true. That's not 180. And I know some of you are going to be confused about whether or not it's like this or if it's more like this. but you can figure it out. My first advice is to figure out, before you even go the next place, I would figure out what all these angles were. That angle, and oh, those are all 90s, so that's pretty obvious. And then transfer them up here so that you know what this angle is and what that angle is. Get all your angles figured out before you move on to the next thing. How many of you realized that this was 20, and therefore this was 20, and therefore this was 70? Is that making sense so far? Okay. Now, if you're going to go 160, double checking. You are right, thank you. I apologize, I was looking at this one, and I was saying it was 20 degrees off of 180. I thank you for catching that. That would have messed us really up pretty bad later. Sorry. Okay, so this angle right here was 10. So then this one's 10. So then this one's 80. And this one's 80. There. That's what it's good to have a partner for. Good catch. Okay, now we have to go 160 true. Well, this would be 90 true if I went directly that way. That'd be too easy. 90 plus what would make 160? 90 plus what would make 160? 70 more degrees. So, in case you haven't figured it out yet, this would be 80 degrees. So it is heading back in that direction. And notice, it's got to be 5 compared to 2. 5 miles in that direction compared to 2 miles. So there, I'm getting close. Now I'll let you finish this up, and your goal is to try to find this pink dotted line right there. You're going to find 3 right triangles, 2 of which you'll have sides and angles. The third right triangle is kind of useless because you don't know any sides or angles, but you can figure them out from those 2 good right triangles that you will have. All right, pause while you finish this one off. No easy way to do this. You can't shortcut it. You got to do it yourself. Okay, so there's the right triangles that go around the outside of it. And we do need to figure out which ones have a side and which ones don't. This one has a side of 5, so the bright blue triangle is a good one because I've got an angle of 80 here, and I got a side, so I can know the H tote, horizontal total, and V tote, vertical total. All right. This is my most useless triangle right there because I don't have any sides or angles in it. Okay. 12-minute warning is going off. I'll tell you in a minute what your homework is. All right. This one I can know because the bright green dotted triangle there has got an angle and a side. The side length was 2, because it says so right here. The red line, if you can still see it in there, the red line is 2 miles long, the hypotenuse. All right. And so do you get to find this side that I said is like the most hopeless one to find? You know this one, and you know this one. So you take the vertical total minus V1, and you get V2. All right. Here's some numbers to make sure you're doing it right. How many of you got 1.71 for this top distance? Raise your hand if you did. Okay, good. You're on the right track. This vertical total distance, that one was 4.7. Who got 4.7 for that distance? You're doing it right. Okay. Then, this little number here, 1.97, I think that's this one. Can anybody verify? Is it this one? Okay, it's 1.97. All right. And then the missing V2 then, well, you take 4.7 over here, and you'd subtract this 1.97. And I'll do it on the calculator. 4.97. Nope, 4.7, sorry. 4.7 minus 1.97 gives you 2.73. This side right here, 2.73 on that side. And then h tot was 1.71. H2, I don't know, but H1 I can know. Help me out. What's this bottom one come out to? Somebody who's gotten all of them right so far, you're going to have this one right. This one down here, what's this one? 1.46? 36? Thank you. 1.36. And then it's just Pythagorean Theorem. A squared plus b squared equals c squared. So then I'm going to do the square root of 1.36 squared plus 2.73 squared. Now, do you get I did some rounding, and so did you, and therefore my answer of 3.05 might be just a tiny bit off of what you have? Who had 3.05 or close? Okay, good. All right, that's how far you were from your starting spot where your ship sank. Okay. So, I want to remind you about one more kind of problem. This hasn't gone away. We still need to know how to do this kind. And all I need you to do is set up the equation. Get me one equation that has just x's or h's in it. It'll start with two equations, but then you can get it down to one equation really quick, because I made this one a nice one, because it's got a 45 in it. You should be able to get me one master equation, and if you solve that, you'd know x or h. I'll pause for a second. Let's just set that one up, see if your partner gets the same thing as you do. Your answer is like tangent of 40 is equal to h over q, that kind of thing. Get me an equation you could solve that only has one variable in it. Okay, you should have said that the tangent of 45 is h over x, and then you should have gone, but wait a minute, tangent of 45 is 1, so wait a minute, h and x are the same, because this is like a 45, 45, 90, h equals x. Multiply both sides by x. And do you see that h equals x? Now, is that an equation I can just solve? No, because it's got two variables. So I need the other equation. Tangent of 30 is equal to h over 8 plus x. And then, I don't care if you substitute for x or for h, but x is equal to h. So I'm just going to replace that h with an x. There's your equation. And on a test, are you supposed to leave tangent of 30 on a test? No, because you know what the tangent of 30 is. I can make my little 30, 60, 90. 1, 2, square root of 3. Tangent of 30 is 1 over root 3. You should have just done that one last substitution, and that's an equation that you could have left on the test if we didn't give you a calculator. But if we did give you a calculator, then you'd have to solve it. Do you remember, though, that you could always graph both sides and see where they cross? That's a legal problem-solving method. It's easy to forget, and it's honestly quicker. Your choice. Yes? I'm being vague because I want you to be ready for both. Maybe you'll have a calculator part of the time. Maybe you'll have one all the time. Maybe you won't have one at all. You have to be ready for anything. All right. Now, what's your homework? Your homework for tonight is a quiz. I could have, my life would have been so much easier if I'd have just given you this quiz in class and then said go home and grade it. But I think it's better for you that we did some more problems together in class where I could kind of talk you through them. Your homework is these two questions. It's under today's date in Schoology. It's the 10-2, 10-3 quiz. It's got two questions. They're all set up for you. There's a picture drawn for one of them. The other one, you'll have to make like one of those bearings problems. And there's a key. Remember, just like always, it's not wrong to look at the key. It's only wrong to just copy the key. You have to like use it to help yourself. When is the test coming on this stuff? Friday. All right. Last thought on that. Tomorrow we will go out to the commons and we will do a measuring the height of the commons thing where we use right triangles. You'll take just the data tomorrow as part of our review day. Okay, that's all I've got for you for today.